In this video, we're going to talk about radical expressions, simplifying radical expressions, combining and doing simple operations with radical expressions, as well as rationalizing the denominator. So the first thing we want to do is we want to basically have a quick chart of square roots for basic reference. And again, this is the idea that a square root of any number is the number times itself to get the original. So let's make that quick chart. And there's a quick chart. Of course, we can go on into an infinity for this, but the square root of 1 is 1 because, and square root of 4 is 2 because I can say that 2 squared is equal to 4. So 2 times 2 is 4, so the square root of 4 is 2. And for this first one here, when we're trying to simplify, if I have a perfect square, like I do right here, well then the square root of 25 is simply going to be 5. That's easy to do. But when I'm looking for the square root of 48 or the square root of any of these other numbers that are not perfect squares, then what I have to do is I have to break them down into what I can take the square root of and what I can't. And what that means is we have to use this product property of square roots. And the product property of square roots is that if I have a square root of any two numbers multiplied, I have a and b, it's the same as going the square root of one and the square root of the other. So we're going to be using that going back and forth in these problems here. So when we don't have a perfect square, like the square root of 48, what we're going to do is we're going to break it into what we can take the square root of easily and what we cannot. And what I mean by we can take the square root of easily is one of these perfect square factors. So I'm looking for the values that will divide evenly into 48. And as I'm looking at this, obviously anything bigger than 48 is not going to work. So we're going to see if 36, 25, 16 will, as well as 4. But what I do is I always choose the largest. So as I'm going through the numbers that might possibly divide into my original value under the radical, I'm going to start with large and work my way down. So I can choose 4, but it's not the largest, so it means I might have to break it down later. But what we're going to do is we're going to choose the largest one to make my problem simpler. So that means that 48 can be broken down into two products or factors, meaning that I can take the square root of 16, and if I divide it out, 48 is 16 times 3. Every time you split your radical into two factors or a set of products here, is that it has to be multiplied to get the original. So I can take the square root of 16 easily, which is 4, but what I can't take the square root of, that stays underneath. And that's simplified. And what we're going to do is we're going to see, hey, is there anything else that will divide evenly into 3 out of my perfect squares? And since 1 is the only one that can, my problem is done. So let's go on to 72. Again, working down, I'm starting here at 81, here, but then I'm going to work further down. 64 doesn't divide evenly, 49, 36 does. So I break this down into 36 and 2. Now, one of the things that I have students do a lot is that they forget what does go under the radical and what doesn't. Once I take the square root, so the square root of this is 6, I no longer write it under the radical like that. I'm not going to keep it under the radical because I've used it in essence. So the square root of 36 is 6, but the square root of 2 is irrational, or it's not a perfect square, so I can't do anything more than that. Now, when I have this value here, I'm trying to simplify the radical. So I'm going to start at 32, and I'm going to work my way up till I get to 16. So this is the square root of 16, and this is going to be 16 times 2. And at the time, I haven't taken the square root of anything. But the thing I have to remember is that that negative 6 is just part of the problem over here. It's going to come down later. I'm just going to keep carrying it down until I happen to evaluate it. So I take the square root of 16, which is 4, and the square root of 2 is irrational. I can't. Now again, I don't take the square root again. I've taken the square root, I've used it, but I have to remember these two values are multiplied. Oops, didn't mean to tap that there. So at the very end, to simplify, we're going to do the negative 6 and the 4, which got already taken the square root of, and then we're going to take that out to this side and just multiply those together. So negative 6 times 4 is a negative 24, and the radical 2 stays underneath. So pause the video for a second and see if you can't get the other answers. And here are the answers here. If you notice, the numbers written in black are ones that are part of the original problem, but we can't forget to multiply those in when we are done. When we're simplifying values that have exponents, then we have to remember that in taking the square root, what we're doing is we're breaking it down. We're basically taking half of the exponent, because remember that if I want to take the square root of x to the 6, that means what value times itself, which is thirds. Because when we have two exponents or two values multiplied together, we add the exponents. So the square root of any exponent is simply taking it in half. Or if you remember from other lessons, the root is going to be the denominator. So basically we're taking this in half. If I was taking the cubed root, I would divide it by 3. But taking the square root, the square root of any exponent is simply dividing the exponent in half. So if I was to take the square root of the y to the 10th, it would be y to the 5th. But what on earth do I do if I can't take half of it and get a perfect integer exponent? Well, we do the same thing that we did before. We take it what I can take the square root of. Well, I can take the square root of the largest even exponent, and there's going to be one x left over. So when we take half of that exponent to take the square root, it's x to the 4th, and I have 1x left over. Let's look at this one. We're going to take the square root of 16, we're going to take the square root of x to the 7th, and we're going to take the square root of y to the 10th. Square root of 16 is a perfect square. We can go back onto that chart. Now the square root of 7 is not a perfect square. It is not an even exponent, so I've got to break it into what I can take the square root of and what I cannot. This one is even. It is a perfect square, so I can simply take half of the exponent. So this is 4 still there. Half of this exponent is x cubed. This x, I'm going to actually move it out to have all my radicals out here, and then I'm just repositioning because multiplication is commutative, so we can do that. Let's look at the next one, square root of 96. Well, I can't take the square root of 96. That's not a perfect square. So what I can do is I can take the square root of 16, and then that's 6. And again, every time I'm breaking this down, before I take the root of everything, I should be able to multiply these two values to get my original back up here. Then I can take the square root of x squared, and I can take the square root of y to the 4th. So the square root of 16 is 4. The square root of 6 is irrational. I can't do anything with that. The square root of x squared is simply taking half of that. I'm going to put x to the 1st just to remind myself. And then the square root of that is y squared. So we like to put all of our all of our values that aren't under the radical out in front. I'm not going to write that x to the 1st. And then the other value here. So go ahead and do 13 and 14. Please keep in mind that those values out on the front still have to be taken into account. And here are some answers for some other ones. The one thing I want to emphasize with 15 and 16, again, we split this off into two things that were multiplied. The 49 was multiplied by the x minus 3 squared, and so we could take the square root of 49. I could take the square root because the entire value was squared, so the square root is outdoing the square. Same thing when I factored this. This was a perfect square trinomial, so the square root outdoes the square. Here's one thing. You cannot do this. If I had something like this, x squared plus 25, you cannot say that that is the same as x plus 5. You cannot take the square root of different pieces of a polynomial. This is not allowed to be done. What you have to do is you have to find out if there's factors. Every factor has to be able to take the perfect square or be able to simplify it. But you cannot take the square root of pieces of a polynomial. In the next video, we're going to talk about addition and subtraction of radical expressions.